let's see how to determine whether two vectors are parallel. So it says here two vectors, vector v and w, are said to be parallel if there is a non-zero scalar alpha, so some number, so that one vector is a scalar of the other. So in this case, the angle between the two vectors is either 0 or pi. So let's look at an example. So if I have vector v is 3i minus j, and I have vector w, which is 6i minus 2j, and I want to know if these are parallel. Well, they are, because if you notice, vector w is 2 times vector v, or you could even say vector v is 1/2 of vector w. So notice 3 times 2 are half of 6, and then 2 times -1 are half of -2, and we get the same answer. And so this value right here, and that value, is what we're calling our scalar. All right, if we want to figure out if we have, oh, and let's go back here. We said that the angle would either be 0 or pi, so I could check the angle. So if you remember, the angle between two vectors, hello, go back. So if you remember, we said the angle between two vectors, we use this formula. So cosine alpha, and then we use the dot product. So the dot product between these two vectors, and then plus -1, -2, and then divided by their magnitude. So 3 squared plus -1 squared, and then this piece 6 squared and -2 squared. So let's see what we got here. Notice up top I have 3 times 6, which is 18, plus a negative times a negative, so that would be 20, right? And then on the bottom I have 9 and then 10, so the square root of 10. And then this other piece here would be 36 plus 4, right? So 36, 6 squared plus 4 would be 40 squared. And so looking at this, if I now take and just throw this straight into my calculator, and I do the inverse, because I want to solve, I don't mean to do that, I want to solve this for alpha. If you put that in your calculator and you do the inverse, you're going to see that the top is 20, the bottom is 20 as well. Do you know why? Remember, you can multiply those, so that's the square root of 400, and so 20 over 20, and I inverse both sides, and I get 0. So my angle is 0. So just kind of a proof, because based on what it said, is if they're parallel, then the angle between should be 0 or pi, and it was. If we want to look at orthogonal, okay, so the angle between the two vectors is pi over 2, and we call these orthogonal, and this is typically what they look like. All right, so v is orthogonal to w, and the two vectors are orthogonal if and only if their dot product equals 0. So we can do an example of that. If I have this vector v, 2i minus j, and vector w, 3i plus 6j, and I find their dot product. So their dot product would be 2 times 3 plus -1 times 6. So as you can see, 6 minus 6, which is 0. So they definitely are orthogonal. And if I graph these, remember that If I actually plotted these out and graphed them, you would see that they are orthogonal with each other. Okay, so the last part's an application. How you compute work is done by a force in moving an object, defined as our force vector times some other AB, where F is the amount of force in the direction of AB, and AB is the distance. Work is commonly measured in foot-pounds or in Newton meters, joules. So I have this girl that's pulling this wagon with a force of 50 pounds. How much work is done in moving the wagon 100 feet if the handle makes an angle of 30 degrees with the ground? So let's see here. So I know my magnitude of my force vector is 50 pounds, because it told me that right there, right? And so AB would be the motion. And if I put this on a, say, an XY axis, well, notice it said moving the wagon 100 feet. So the motion is going from, let's just say, the origin, like I drew up above, to 100, 0, the point. And so in other words, this is moving my horizontal component, so 100I. And thus I can find my force vector by the magnitude times the cosine of my angle, which is what, 30 degrees, and then plus sine of 30 degrees. And so that becomes 50 cosine of 30 degrees, square root of 3 over 2. And sine of 30 degrees, 1/2. And so just halving the 50 out front, we get 25 square root of 3I plus J. Okay, so in other words, we just took 1/2 of 50. And now we throw everything into the work formula. So the work formula says take what we just found and then multiply it by that distance. So 25 square root of 3I plus J times 100I. Just simply multiplying out the I values. Why are we only concerned with the I values? She's not going up and down, right? There's no vertical motion at all. There's only the horizontal. So multiplying the horizontal out only, you should get 2500 square root 3 foot-pounds. Okay, and that finishes up this section.